Hello everyone. So today we will be talking about multiple server infinite queue length model. So already we have covered two models in queuing theory. One is single server queuing length model, a single server infinite queue length model. So let us see. We have talked about single server infinite queue length model. And we have covered multiples, not multiple, it's a single server finite queue length model. Clear? So can we remember, or can we recall all the formulas which we have used? So in the single server queue, how it was like denoted, it was denoted in this way: m1 and infinite. Here we have written fcfs. So sometimes this will not be written. It is obvious that it's fcfs, so no, there is no need of writing that. So even the model is denoted in this way. So in this case, we know that this is arrival pattern, which is lambda per hour, and this follows Poisson's distribution, and this follows exponential distribution service rate, which is mu per hour. So we have calculated lambda rho, we have defined rho. This is utilization factor, which is equal to lambda by mu. Now in case of infinite, it should be less than 1, and we have defined probability of n customers in the queue. So that is how much? Rho to the power n into p naught. What is p naught? That means there are 0 customers in the system. Oh, this is pn is equal to n customers in the system, and p naught is equal to customers in the system, that is 1 minus rho. And we have defined ls, which is how much? Rho upon 1 minus rho. lq is equal to ls minus rho. ws is equal to ls upon lambda, and wq is equal to lq upon lambda. So these are the formulas which we have used. So now we will see, in case of single server finite queue length model, in this case what we have seen. So here we have how we denote it: m1, and here it is n and infinite, where n is the system capacity. So system capacity is equal to n. Here also lambda is rho is equal to lambda by mu, and this may be equal to 0, that this may be like less than 1, this may be greater than 1, this may be equal to 1. Any possibility is there. So we know pn, it will be same. What about p naught? So there is a change: 1 minus rho divided by 1 minus rho to the power n plus 1. What is ls? So ls is equal to rho by 1 minus rho. The extra term, which is just one thing. This is n p to the power, oh excuse me, this is not p, n into rho to the power n plus 1 minus n plus 1 into rho to the power n plus 1 divided by 1 minus rho to the power n plus 1. LQ is how much? LS minus rho effective. Here we have to calculate rho effective, where rho effective is equal to lambda effective divided by mu. What is lambda effective? Which is lambda into 1 minus lambda into 1 minus Pn divided by mu. So these all expressions we have derived in the last class. Now Ws is equal to Ls divided by lambda effective, and Wq is equal to Lq divided by lambda effective. So these are the expressions. So let us see the last today's model which we are going to discuss, that is multiple server infinite queue length model. Okay, so here the service rate, how we will denote first, MM1, here 1 will not be there, so it will be C, and this will be infinite, where C is the number of servers. Okay, now here we will write rho is equal to lambda by mu, but we are not interested in this term, we are interested in this term, lambda by mu C, and should be less than 1 because infinite queue length model, or we can write rho by C is less than 1, where what is rho mu into C. So this is service rate for one server, here number of servers is C, so this term has become mu into C. Clear? Now what are the expressions of Pn and P naught? So the expression for Pn is equal to, there are two parts, like the expression there are two expressions in it. One is rho to the power n divided by n factorial into P naught when n is less than C. This is n customers in the system, and that is equal to rho to the power n by C factorial into C to the power n minus C into P naught when n is greater than or equal to C. So this is Pn value. Now what will be P naught? So P naught is given with the expression 1 upon sigma 0 n is equal to 0 to C minus 1 rho to the power n divided by n factorial plus rho to the power C by C factorial into 1 by 1 minus rho by C. Okay, so this is one term and this is another term. Now another expression which we have to remember is LQ, length of the queue. So this is how much is rho to the power, excuse me, okay, rho to the power c plus 1 p naught divided by c minus 1 factorial into c minus rho square. Okay, rest other things, ls is equal to lq plus rho and ws is equal to ls upon lambda, wq is equal to lq upon lambda. So this is the expression for the multi-server infinite queue length model. So only in this we have to remember this expression, this one and this one. These three expressions we need to remember in case of multiple server infinite queue length model. Okay, now we will talk how to derive these expressions. Okay, so let us talk about that. So multiple server queuing model is denoted by the following symbol or following notation. So multiple server queuing model with infinite queue length Okay, so how we define it, how we denote it? This is m, here it will be c, then infinity. So this c is actually number of servers. Here we have the arrival rate is lambda, and the service rate per server is mu per hour. So lambda is arrival rate per hour and mu is service time, or you can say service rate per server by a single server. This is, so if there are c servers, so how much will be the service rate? That is mu into c. So in this case lambda upon mu c should be less than 1, or we can say lambda upon mu is equal to rho upon c should be less than 1. So this is the condition. So this is basically let's suppose like we have 3 servers, okay, and the line is individual, one single line, there are no multiple queues. Okay, so from this single queue, this server, let's suppose this server is free, so this customer will go here. After that this server got free, so this customer will go. So in this way this is working. Okay, so the effective service rate we have seen mu c. Okay, so let us talk about, let's suppose there are n customers. Okay, so what will be the service rate? So if we say if there are n customers in the system, then service rate is same, because with this service rate only lambda per hour people are coming. But what about mu n? What will be the service? This is arrival rate and this is service rate, mu n. So what will be mu n? So this can be as we have seen, in case the servers are c, so this will be mu c. But if there are n customers, so how we can say? That will be n into mu. when n is less than c, and this will be c into mu when n is greater than or equal to c. How this expression is coming? So let us see here. Okay. So look at this. Let's suppose there are 4 servers or 5 servers. Okay. In queue, this is c is equal to 5 here. In this queue, let's suppose there are 3 customers. N is equal to 3. So they will go where, at which servers? They will approach to 3 servers. They will get their service done, and 2 will be idle. So what is the service rate now? Effective service rate? Mu 3. Actually there are 3. So only per server the service rate is mu. So 3 servers are engaged, so 3 mu. If there are 4, n is equal to 4. In that case, mu 4 is equal to 4 mu. If n is equal to 5, then this total will be engaged. So 5 mu is the service rate, effective service. If n is 6, then what will happen? There are n customers, that is 6 customers. So 5 will be getting their service and 1 will be in the queue. So what is the service rate? N6, that is again 5 mu. Why? Because 5 servers are busy. So each server, the service rate is mu. So 5 servers, 5 mu. Whether the n is equal to 6, 7, 8, 9, 10, whatever it is, means n, if it is greater than or equal to c, then that in that case this will become c into mu. But in case when n is less than c, then the service rate will be n into mu. Clear? Okay, so now we have seen we require what all expressions. We require Pn, we require P0, we require Ws, length of the system, we require LQ, we require Ws and WQ. So these are the terms we need to calculate. So let us start with Pn. So here we know, like in general we have seen already that Pn is equal to how much? Lambda Pn is equal to rho to the power n into P0, or you can say lambda to the power n divided by mu to the power n P0. We have seen this, rho to the power n into P0. Clear? But here since we are using this one, so this will change. So Pn can be written as lambda upon mu into lambda upon 2 mu into lambda upon 3 mu. Like this it will go on up to lambda upon n mu into P0. Same thing can be written as like this, where n may be greater, may be less. Okay, if it is less, then only this formula will be applied. So this is the case when n is less than c. So how we can write? This is how many terms? 1 mu, 2 mu, 3 mu, up to n mu. So total n terms are there. So it can be written as lambda to the power n. This is mu. All mu's are total n mu's. So mu to the power n. And we got this is 1, 2, 3, 4 up to n. So 1 into 2 into 3 into, that is 1 by n factorial. 1 by n factorial into P0. So this is the formula. So I'll write here. Okay, look at this. So we can write Pn is equal to lambda to the power n mu to the power n 1 by n factorial into p naught, or Pn is equal to, this can be as rho to the power n divided by n factorial into p naught when n is less than c. So this is the formula that we have to remember. Clear? Okay, so next, what will happen if n is greater than, in case if n is greater than equal to c, then what will happen? So here it will go up to c, not up to c. It's like up to n minus c minus 1 actually. Up to c minus 1 it will go, but as soon as it will reach to, see here, take an example of this one only. Okay, take this example, and how we can write Pn in this case when n is equal to, n is greater than or equal to c. So this will go up to how much? Lambda by 5 mu. What will happen? Because here c we have taken 5, so this will go up to 5. After that all the terms will have this expression only. Okay, this will continue up to where? Up to n, isn't it? So this will continue up to n. So like this, lambda by n mu. Actually, sorry, 5 mu. This will continue up to n. This is the nth term. Okay, this is nth term, and into p naught. This will be the expression. Okay, so how we can write here? So how many terms are there? Total n terms. It is this one is the nth, so lambda to the power n. Mu also total n, mu to the power n. Okay, this one is up to 5. That means up to c. So this is c factorial. So 1 upon c factorial. After that, how many remaining are? So this much is c. From here to, sorry, so up to here it is 5, or you can say c, and after that out of n, this is n minus c, so total terms will be n. So this is n minus c, a lambda by 5 mu. How many are remaining? This is n minus c. So we can write like 1 by 5, 1 by 5. How many 1 by 5 is coming? Is n minus c, or you can say 1 by c, 1 by c, 1 by c, like that. How many 1 by c are multiplied? Total n minus c terms. So can we write 1 by c to the power n minus c? Correct? And after this, p naught. So this is the expression, lambda to the power n, mu to the power n, 1 by c factorial, 1 by c n minus c p naught. Okay? Okay, so next we got Pn. We got Pn is equal to, how much we got? Lambda to the power n by mu to the power n, 1 by c factorial, and 1 by, it was c to the power n minus c into p naught. So this was the formula when n is greater than equal to c, or you can say rho to the power n by c factorial, c to the power n minus c into p naught when n is greater than c. So this is, so now we can finally write Pn is equal to, what is the formula? So when n is less than 1, and it is rho to the power n by n factorial into p naught, in case n is less than c, and is equal to rho to the power n by c factorial into c to the power n minus c p naught when n is greater than equal to c. So this we have to remember. Okay. So we got the formula. Okay, but what about P naught? We don't know what is the expression for P naught. So let us calculate that one. Okay, so P naught, we know P naught plus P1 plus P2 like that. It will go up to P infinite. It will go, actually it will continue till infinite, isn't it? Is equal to, because how many customers can come? So the probability of 0 customer, probability of 1 customer, probability of 2 customers in the system, probability of infinite customers in the system, all added should be 1. Okay. So let us see, we know Pn expressions. So can we write up to n, like n when it is less than c? So less than c means it should be c minus 1. So up to c minus 1. That means n is equal to 0 to c minus 1. What will be the expression? Rho to the power n p naught divided by actually n factorial, isn't it? And plus from n is equal to c to infinite, what is the expression? Rho to the power n divided by c factorial n, c to the power n minus c into p naught, and that is equal to 1. So p naught we will calculate from here. Take out the p naught common, and now we will write n is equal to 0 to c minus 1 rho to the power n by n factorial. Okay, and plus n is equal to c infinite. What I am going to do, c to the power n minus c. So I will make this also n minus c. So what I'll do, I'll take out this. Then this will remain n minus c, and bottom also n minus c, and is equal to 1. Okay. So now this term. So let us see how we can reduce this term. Okay, this we can write. See, this is constant, rho to the power c, because there is no n terms in this, so we can take it outside, and now this is remaining this one. So let us suppose that n is equal to c, then it is rho to the power 0 by c to the power 0, that is 1. So the first term is 1 plus when n is equal to c plus 1, then this will become rho to the power 1 divided by c to the power, that means rho to the power rho by c. When n is equal to 2, this will n is equal to c plus 2, then this will be rho to the power 2 by c to the power 2, means rho by c square, like this. It will continue. So what I have to do, I have to put middle bracket like this. It will go up to where? Infinite. So now this is going up to infinite, and what is rho by c? We have already assumed that this is less than 1. So this is a geometric progression with r is equal to less than 1. So what will be the summation? What is the formula? 1 upon 1 minus r. This is the summation. Okay, so we will use this formula only. So right here, p naught this is sigma 0 to n minus c minus 1 rho to the power n divided by n factorial plus rho to the power c on c factorial, and what is 1 by 1 minus r, that is 1 by 1 minus rho by c. is equal to 1. So now P naught will be 1 by this expression. Okay, so we can just write here P naught is equal to 1 divided by sigma 0 to c minus 1 rho to the power n by n factorial plus rho to the power c by c factorial 1 by 1 minus rho by c, and just the bracket here. So this is the expression for P naught. So we got two expressions, Pn and P naught. So Pn, P1, P2, P3, whatever we want, we can calculate. That is number of customers in the system we can calculate from here, where P naught can be calculated from this expression. Okay. Now we will calculate LQ, LS, WQ and WS. So these two expressions are needed. Okay, so what I'm going to do, so we need to remember this expression and this expression. We will calculate LQ. We will find out the expression for LQ. So LQ means length of queue. So when the queue formation will happen, let's suppose I told that there are 5 servers, okay, and people are coming. So till 5 customers come, then all will get the server. So there will not be any queue. As soon as the customer 6th one will come, then there will be a formation of queue. That means till n is equal to c, there will not be any queue. Okay, so obviously we are not going to use this term here. We require this term. So what we will do, right? We require Pn when n minus c, and that is from n is equal to c to infinite. So this we require. Okay, so let j is equal to n minus c. So put it there. This will be j is equal to 0 to infinite, and this is j into p. This will be c plus j. Okay. Now what is the expression for this one? We will use this term, j is equal to 0 to infinite j into rho to the power c plus j. See here, n on the place of n we will write, so rho to the power c plus j divided by c factorial, and c to the power n minus c is j, so this is j, and into p naught. Okay. So now what I'm going to do is I'm going to put it into differential form. So how we can write, so we want this one rho to the power j minus 1 term, so we can write c plus 1, okay, and then it will remain j into rho to the power minus 1. Okay, you see, if we add both the things, then it will be c plus j. Okay, it is correct. Then c factorial, c into, we have taken out c and we will write j minus 1. Okay, why actually this one? Because we want to write it into differential. There is a summation here, so we want to cancel the summation with the integration. Sorry, summation with the differentiation. This one is constant, Oh, P naught is left. P naught we can take out. C factorial will be taken out into C. Okay, and here this is remaining j into rho to the power j minus 1 c in j minus 1. So rho by c to the power j minus 1. That means we can write differential of, with respect to the rho by c, this is rho by c to the power j. This is the differential, and we can, what we can do is we can okay, put the summation here, j is equal to 0 to now just exchange this. So differentiation, take out outside, and take the integration. So d upon d of rho by c into integration of rho by c to the power j when j is equal to 0 to infinity. Again you see this term is a geometric series, rho to the power c to the power 0, that means 1 plus rho by c plus rho by c squared. So this is the summation of this will be 1 by 1 minus rho by c. So we can write rho to the power c plus 1 p naught by c factorial c into d upon d into rho by c into 1 divided by 1 minus rho by c. This is not into, actually, derivative. Okay, so this term we got, this cancel if we consider rho by c as u. So what I'm going to do is rho to the power c plus 1 p naught by c factorial c. So how we can write the differentiation of this will be 1 upon 1 minus rho by c to the power 2. Okay, because the variable is rho by c, so there is no problem, there will not be differentiation of rho by c. Okay, so you know the differentiation. See, if rho by c is considered u, just take it. So what will happen, d upon du of 1 by u square, sorry, 1 by u. So what will be the differentiation of this one? So oh, actually this is not 1 by 1 minus u. Okay, and so what will be the differentiation? This is 1 by x, so x to the power minus 1 minus u to the power minus 1 d of du. So what will be the differentiation of this? So minus 1 into 1 minus u to the power minus 1 into, this is minus u, so what will be the differentiation of minus u? That is minus 1. So minus 1 is equal to plus, and this is 1 minus u to the power minus 2, that is 1 by 1 minus u square. This is what I have written here. Okay, so there should not be any confusion in the differentiation. So take care of the sign, that it should be positive. Two negatives will become positive. So now we can write c plus 1 p naught divided by, okay, here what will happen, that if we write this here we put c, so c minus rho by c square. So c square and this one, it will be cancelled, so we will get 1 by c. That means the one c is removed, so we will get c minus 1 factorial, and here we are getting c minus rho square. Okay, so this is the expression for LQ. So we have got these three expressions. We in this model, we have to remember only these three expressions. What is the expression for Pn? what is the expression for P naught, and what is the expression for LQ. Now can we calculate LS? So LQ plus Q plus rho, where rho is equal to lambda by mu, and WS is equal to LS by lambda, and WQ is equal to lambda. So in this way we can calculate. Okay. So let us solve one example. Here one question is that people arrive at a web browsing center at the rate of 10 per hour. Poisson arrival. So lambda is given 10 per hour. There are 2 computers used for browsing. That means number of servers are. The expected time taken by a person is 10. That means service rate mu is equal to 10 minutes, means per hour how many? So 60 by 10, that means 6 per hour. So it is asked that, let us see, it's asked the probability and all. So first of all we need to check this one. Is it less than 1? 10 upon 12 less than 1. Yeah. Okay, so now we will go for first question. What is asked? Probability that both the computers are free when a person arrives. That means there is no customer in the system. We need to calculate P naught. We know the expression for P naught, isn't it? So we can put the values, these values inside the expression, and we can calculate it. Next one is the probability that the person can use the computer immediately on arrival. As soon as he comes to the computer center, then he gets a computer. That means there are 2 servers, 2 computers are there. So if a person arrives, when he will get a computer? When there is no customer in the system, or there is only one customer in the system, then only he will get this. Okay, because another one is like vacant. See, the probability that there is no queue on arrival. As soon as one person comes, he sees that there is no queue. When it can happen? When either there is no customer in the system, so there will be no queue, or there may be one customer in the system, then also there will not be queue, or there is a chance that there is 2 customers in the system. Here we can write what? P naught plus rho into P naught, that is P naught into 1 plus rho. Clear? So this expression, oh sorry, this will not be rho into P naught. No, there is an expression for Pn. We have to use that one. So this will not be. Okay, we need to go for another expression. Okay, anyway, and we'll solve it, and so this will be the equation. Okay, fourth one, the expected number in the system. Okay, so in the system means LS, so that will be LQ plus rho. And what about E? Waiting time in the queue, WQ, that is LQ upon lambda. So these all terms we have to calculate. So try this question. Okay, one question and we'll be solving, that is P naught. After that you can, so what is the expression for P naught? We have already got the expression, that is 1 by n is equal to 0 to c minus 1 rho to the power n by n factorial plus rho to the power c upon c factorial into 1 minus rho by c. This is the expression for P naught. Can we write P naught? So n is equal to 0 to c minus 1. Okay, so that means we have to go for up to n is equal to 0 to 1. So when n is equal to 0, this will be 1. When n is equal to 1, then how much? This is rho by, oh, rho only, no? so there is no down, it will be row only. Okay, plus here what is c value is 2 here, so next term will be 2 divided by 2 factorial upon 1 by 1 minus what is the value of row. Okay, that is row, how much is row on mu, no? So lambda upon mu, so this is 10 by 6 upon 2. Clear? So 1 upon 1 plus 10 by 6 plus row square, that is 100 by 36, 2 factorial, 2 into this is 100 by 36, row is equal to 10 by 6, so 10 by 12, so 1 minus 10 by 12 is equal to 2 by 12, 1 by 6, that is 6 ever. Okay, so this is 6, how much is that? 1 plus 10 by 6 plus 10 by 12. So if we have calculator, then we can calculate. Minute, let me find out how much is this coming. 1 plus 10 by 6 plus 100 by 12, that is 11, so 1 divided by 11 is equal to 0.0909, so the value is coming is 0.0909. that means the probability that there is no no person is there, that is 9%. Okay, now p1 can be calculate, that is expression we will use, pn expression we will use. So when n is less than 1, so we will use this expression, that is rho to the power n divided by n factorial into p naught, because n is less than, that means 1 is less than 2. So this is 1, that means rho by 1 into p naught. So rho is, here we have 10 by 6 into 0.0909. How much is that? This comes 0.1515. Clear? So we got 0.1515 P1. So now we can put it here. So B will be, this is A, B will be P0 plus P1, which is how much? Add both the things, it will be 0.2424. Okay, so in this way you have to calculate C also, and then LS and all the terms. Okay, so try this at your place and submit in the quiz. Thank you very much.